before humans existed. So my favorite place where these numbers come up is, of course, in nature's art. So what happens is, of course, there are many other places where these numbers come up. There's actually a whole journal in mathematics called the Fibonacci Quarterly that's dedicated to just these numbers. That's how rich these numbers are. But let me tell you how they come up in nature's art. So if you look at daisies, it turns out that the number of petals on a daisy tends to be one of these numbers. So for example, here's a picture of a daisy. And how many petals do you see? 13, right? This daisy has 13 petals, which, as you know, is one of the numbers in the Hemachnder Fibonacci sequence. And if you look at, here's another picture of a daisy, and if you count the number of petals on here, you'll find that there are 21 petals. So the number of petals on a daisy tends to be one of these numbers. There are daisies that have 13 petals, there are daisies that have 21 petals. And this is my favorite picture. This is a picture of an entire garden of daisies. And it turns out that each one of these daisies has 34 petals, which I know because I actually sat there and counted all of them. So these all have 34 petals. It's amazing that they all know how to go to the number of rhythms having 8 beats. So the flowers go straight to those numbers, 34, in this entire garden. And it took a while for mathematicians and biologists to understand why daisies tend to have this particular number of petals. And it's kind of understood now, though not really fully, but it's understood in a mathematical way that has its origins in biology. It has to do with the fact that petals grow out of seeds that spiral out in the center, and the tightest way to pack seeds in the center, it turns out, occurs when each additional seed that's sprouted turns by what's called the golden angle. And that gives the tightest packing of seeds. And when you go around the spiral 8 times, and you count the number of petals, you get 34.